Hello everyone and welcome to Probability and Statistics. Today we're going to work with continuous random variables. So we're given this function of x and y, which is equal to c of x plus y, and we need to figure out what c is so that we have a joint PDF over this range of values. And since we're using greater than or equal to signs, you know that it has to be a continuous random variable. So the way you set this up is, what I like to do first is actually draw a picture of what we have to work with. So you set up what this actual range is going to be in order to figure out what the probability in C will be over that range. So we've got x from 0 to 3. This is x and this is y. We've got 0 to 3. I'm going to put 3 right there. And then you've got y from x of x plus 2. So if you've got y is equal to x, well, that equation is just a straight line. And then if you've got y equal to x plus 2, well, that's just a straight line plus 2. So it's going to cross right here at 2 and continue on upward to 45 degrees. And then 3 is going to cut off right here. So then the area where this joint density function is going to be valid is right in here. And that's where your joint density function is going to be valid. So basically, in order to figure out what C is going to be, you use the equation, the integral of x, the integral of y, of your function fxy of x by y dx dy is equal to 1. And this is how you start solving for C. Because this immediately goes, I'm going to go ahead and move down here. The integral of x times the integral of y of C of x plus y dy dx. Sorry, I got those backwards earlier. Your first dy should always be with your first integral, or your last integral. Okay, and then you work outwards like this, if you're not familiar with integrals. Okay, so then going on with this, you can go ahead and take the c on the outside and then put in your values for x and y, your range. So x goes from 0 to 3, and y goes from x to x plus 2. So if you go ahead and take the integral, and then you've got x plus y dy dx, which is going to equal c, the integral from 0 to 3 of x plus y, or oops, xy plus y squared over 2, which is just taking the integral with respect to y. You treat x as a constant. And then x plus 2. And if you go ahead, this is going to take you on, we're just going to do the inside here, do some side calcs. X plus 2 plus x plus 2 over 2 squared. Sorry I'm squeezing that, but hopefully you know how to do this integration right here, so I shouldn't have to show it in too much detail. And actually, I'm just going to go ahead and skip that, just for the sake of time. So this is going to equal c, integral from 0 to 3 of 4x plus 2 dx. That's what you should end up with after you do all that integration and reduction and getting it down to a usable system again. So then, that's going to equal c of 2x squared plus 2x from 0 to 3, which is equal to c of 2 times 9 plus 6 minus 0, which is equal, this is still all equal to 1, sorry, let that little piece out. And then you have 1 is equal to c times 24. So c is equal to 1 over 24 for this continuous range. So then our fxy, our joint PDF, xy is equal to 1 over 24 of x plus y. And that is your joint PDF for this problem. So basically what you do is you just sketch out your range, and then you arrange your integrals in order to cover and find the area of this range. Set that equal to 1, and you can solve for C. And that's how you get your joint probability density function. In my next video, I'll expand on how you actually get the probabilities of specific ranges, like what's the probability of getting a value of x less than 1, and that kind of thing. So that'll be in the next video.